Welcome back. We've pushed a long way to get here. A lot of small decisions, careful adjustments, and honestly, a lot of patience. Step by step, we've put in the hard work. And now we're moving into the final stage of this tutorial. This is the moment where everything starts to come together. All of those earlier choices begin to pay off. This is where the glaze finally comes alive, where the material begins to feel real, not just visually, but physically, where Cycles gives us accurate light behavior, believable reflections, and shadows that actually sit inside the scene instead of floating on top of it, and where composition helps guide the viewer toward the final image we want to present. So here's the plan. First, we'll push the donut and glaze materials into the Cycles rendering engine, letting realism take priority over render speed. Then, we'll do some compositing, not to change the image, but to enhance what's already there. And finally, we'll render the scene and generate the final animation. All right, let's begin. For rendering, we'll switch to the Cycles render engine. Cycles is designed for physical realism. It calculates light the way it behaves in the real world. That level of accuracy comes with longer render times, but for a project like this, it's absolutely worth it. When Cycles first starts rendering, the image usually looks rough. You'll see a lot of noise, small grains scattered across the frame. As more samples are calculated, the image gradually cleans itself up, detail by detail, until it settles into a smooth result. Now inside Blender, you'll notice two sampling settings, viewport samples and render samples. They look very similar, but only the render samples affect the final animation you export. Viewport samples exist purely to keep the scene responsive while you work. So for the viewport, set the samples to 32. This keeps the preview light and responsive. For the final render, set the maximum samples to 300. This gives us a solid balance, clean enough to look polished without pushing render times too far. If you have more time or a stronger system, you can absolutely go higher. Rendering at higher sample counts, even up to 1,000, can produce a more refined image. But for this tutorial, and for most practical cases, 32 viewport samples and 300 render samples is a very reasonable setup. Blender also includes a denoising feature to help reduce remaining noise. Go ahead and enable denoising for both the viewport and the final render. Think of it as a final cleanup pass. It doesn't replace proper sampling, but it helps smooth out the last bits of noise and bring the image together nicely. Before we move on, take a careful look at the scene. You might notice something subtle. Right now, two different shadows are being created. One shadow comes from our main Cycles sunlight, the strong, directional shadow. And the other one comes from the sunlight we added earlier for Eevee, the softer, lighter shadow. When both lights remain active, they quietly compete with each other, and the result isn't physically accurate. If you look closely at the sugar glaze, you'll also notice the surface appears a little too bright. That extra brightness and the second shadow are both coming from that earlier sunlight. So for now, let's disable it. Select the sunlight in the outliner, then disable the viewport icon and also the camera icon. There we go. Now the scene is driven by a single directional light. One shadow. Clean and physically consistent. Alright, next, let's adjust the window frame slightly to allow a little more light to enter the room. Select the cube, enter edit mode, press G, then Z, and slowly pull it downward. Just a small adjustment, enough to allow the light rays to stretch a little further into the room. That's enough. Switch back to object mode. Take a look. Nice. The light feels much better now. Now let's finish building the sugar glaze material. This is the perfect moment to do it. Earlier in the tutorial, we were working mostly with visual approximations, but now, under cycles, we finally have physically accurate lighting, so the material can start behaving the way it does in the real world. For the sugar glaze, we'll introduce transmission, and for the donut base, we'll add a small amount of subsurface scattering, just enough to let light do what it naturally wants to do. So first, select the glaze. Open the shader editor and switch to rendered view. Here's the idea behind transmission. Sugar glaze isn't fully transparent, but it's also not completely opaque. Light can pass through it slightly, especially in thinner areas. And that subtle light travel is a big part of why real glaze feels glossy and moist instead of flat. Transmission allows us to simulate that behavior. Set the transmission weight to about 0.4, not too high. We don't want the glaze to look like glass, just enough to allow light to slip through in the right areas. Now, to make this feel natural, we need variation. Real glaze is never evenly thick. Some areas stretch thin as the glaze drips downward. Other areas pool and build up. That variation in thickness directly affects how light passes through the material. So let's duplicate the noise texture and color ramp we're already using for roughness. Then feed that setup into transmission. This noise is not about surface texture. It's not about bumps or micro detail. It's about thickness variation. Now adjust the noise texture. Set the scale to 6. Set the detail to 2. Then move to the color ramp. Set the black position to about 0.18. Set the white position to 0.64. Then change the interpolation from linear to ease. That softer transition is important. What this gives us is natural variation. Some areas allow more light to pass through, while other areas block it slightly. That's exactly how real glaze behaves. But if you look very carefully, you might notice something missing. Light isn't quite traveling through the glaze the way we expect. Ideally, light should enter the glaze, scatter slightly within the thin sugary layer, and exit again, producing that smooth, glossy shine. Right now, that internal light movement feels a bit restricted, and the reason comes from the displace modifier we added earlier. That modifier is altering the geometry. It pushes certain vertices inward and pulls others outward, creating uneven depth across the glazed surface. While that worked well for surface breakup earlier, it also interrupts how light travels through the material. Instead of moving smoothly through a thin layer, the light keeps changing direction because of those geometric distortions. That weakens the soft, translucent glow we're trying to achieve. For sugar glaze, we want a cleaner light path. Light should enter the glaze, move freely within the thin layer, and scatter naturally. So try temporarily disabling the displace modifier in the viewport. Watch what happens. Immediately, the glaze becomes cleaner and more transparent. The light is finally free to move through the material without interruption. And now, the transmission begins behaving exactly the way we intended. Light passes beautifully through the thinner areas of the glaze, creating that glossy, translucent shine you see in fresh sugar glaze. Where the glaze becomes thicker, the light is slightly blocked. The surface appears a bit milky, similar to how real sugar crystallizes when glaze builds up. That variation is what gives the material its realism. And honestly, it's what makes the donut look delicious. From the very beginning of this tutorial, This was our goal. And now we've reached it. So at this point, we can remove the displace modifier from the sugar glaze. However, we'll keep it for the chocolate glaze. Chocolate glaze is thicker, less translucent, and more textured, so that surface variation still works well there. Now a quick but important note. In the real world, light does not pass through chocolate glaze. Chocolate is dense and heavily pigmented. Light interacts with it mostly through reflection, not transmission. So for the chocolate glaze, we don't add transmission at all. Next, select the donut base. Here we'll introduce subsurface scattering. Subsurface scattering simulates light entering a solid surface, bouncing around inside the material, and exiting at slightly different points. It's perfect for materials like dough, soft, porous, and organic. Set the subsurface weight to 1. Now watch the surface carefully. Notice how the light begins to enter the dough, especially around the edges. See how it softly brightens those areas. That's subsurface scattering. Now set the radius evenly on all axes. Set each value to 1. This tells Blender that light should scatter equally in every direction beneath the surface. Next, reduce the scale. Bring it down to a very small value, around 0.02. As you lower the scale, you'll see the effect become tighter and more controlled. This effect should stay very subtle, almost invisible at first glance. It simply gives the donut that soft, baked dough quality. One more note about material behavior. We don't add subsurface scattering to the glaze. Sugar glaze allows light to pass through it, not within it, so transmission handles that behavior much better. And the sprinkles are dyed sugar crystals. They're dense and opaque, so again, no subsurface scattering there either. Each material in the scene is now behaving exactly the way it should physically behave. Now take a moment and look at what we have. This is now behaving like a real glazed donut. What we've built here is a physically believable sugar glaze, a clean shader structure, and a surface where thickness varies naturally, just like real poured glaze. At this stage, the material itself and the way light interacts with it is no longer limiting our realism. But realism never comes from the material alone. As I mentioned earlier, lighting still plays a huge role in the final result. In real food photography, artists rarely rely on a single light source. They carefully combine multiple lights, because one strong light, by itself, rarely produces the depth and highlight behavior we expect, especially for glossy materials like sugar glaze. Beyond the shader, lighting strongly determines how believable the glaze appears. This isn't about color, it's about how real light behaves. Every highlight, every reflection, every refraction, every soft shadow. Those elements define glossy materials far more than color ever could. That's exactly why the shader looked a little artificial earlier inside Eevee. For someone new to 3D, that can even feel confusing. You might look at the material and think, is this really sugar glaze or something fake? But this layered process is exactly how real artists work. And remember, my goal in this tutorial was to teach a production-style workflow, not just how to build a donut. Sugar glaze simply happens to be the perfect example for demonstrating that process. So now, let's refine the lighting once again. Earlier, we added an area light and a sunlight for Eevee. Now that we're working in cycles, we'll keep both of those lights exactly as they are. Open the outliner. Enable both the viewport and render icons for the sunlight. And if the area light is disabled, enable it as well. Now don't follow along just yet. Simply observe. I want to show you the difference during rendering. If I go to render, then render image, this is the result we get. Now I return to layout, select the sunlight, and disable its shadow. Then once again, render image. This is the second result, with the sun shadow turned off. Now one more comparison. If I completely disable the sunlight from rendering, it will no longer influence the scene at all. Now render again. Here we can compare how each lighting configuration affects the scene, side by side, in real time. Take a careful look. When both shadows are active, the image feels less realistic because two separate shadows are being created. Even though we want combined lighting, we don't want competing shadows. Instead, we want one clear shadow from the main light and only soft highlight contribution from the secondary light. So for this setup, we disable shadow on the sunlight. Now compare image 2 and image 3. Image 2 looks cleaner and easier to read. We get that strong specular reflection and a smooth highlight across the sugar glaze. The chocolate glaze also appears creamier, which is exactly what we want. But in image 3, we lose a lot of that surface detail. Chocolate absorbs more light energy than sugar glaze. It's naturally darker. So when the lighting becomes slightly weaker, the light simply sinks into the surface. It doesn't bounce back strongly. And when that happens, the material stays dark instead of looking rich and creamy. So our main sunlight alone is not quite strong enough. It can't fully protect the chocolate surface from falling into shadow. It benefits from that second light source, which helps preserve those soft highlights. And for the sugar glaze, that additional light also helps maintain clean reflections. So for now, we'll keep the configuration from image 2. At this stage, what I want you to understand is how multiple lights work together in a scene. Observe what each light contributes and how small changes affect the final render. However, this still isn't our final lighting setup. It works beautifully for the sugar glaze and chocolate glaze, but it doesn't work as well for the marble, the coffee mug, or the plate. And that's completely okay, because right now we were focused on achieving realistic glaze materials, nothing else. Later, when we refine the entire scene, we'll improve the lighting further. Just like we refined the materials, we'll do the same with the lighting. We'll keep pushing it forward until the scene reaches a strong and believable balance. So far, our process has been very intentional. We started simple. We introduced different light types. We explored their direction and their position. Now we're combining 3 lights, and we clearly understand what each one contributes. Next, we start thinking more like artists. We'll begin using lighting diagnostic tools to analyze the scene, studying exposure and making decisions based on observation. All right,